Hi folks, let's walk through a deep dive on some various different ID boring operations for lathe cam in Fusion 360. My recommendation on how to best use this is to download this file. This is always going to be available under Speeds and Feeds Cam Templates, the lathe cam template. We will keep this updated as we continue to add functionality to it. But we've got three different sections to take a look at here. We're going to turn off the visibility of the pulley, which is another one of our lathe cam templates, so that we can look at this 4.5-inch OD, 2-inch ID turned piece and focus on how we can control a boring bar to get some work done here on the cam side. The first toolpath in 3A is pretty much what you get without tweaking many of the settings. So if you were going to set up some ID work, the way we tend to use lathe operations is we will right-click, copy, and paste it into the new file. It's easier to do that because that's going to bring with it your tool as well as some other settings, like for instance turning mode needs to be set to inside profiling. So we think of this sort of as a mini template, if that makes sense. If we take a look at what this toolpath does, we know if you have much lathe experience, you can't do that. You can't plunge a boring bar into a blind piece of material. At least most aren't what we call center cutting. So a lot of times what you're going to do is drill out a hole first. So 3B contemplates that, and this is the one I would really recommend you use. So we've got an insert style drill modeled up here, 1-inch diameter. Let's assume that we drill through that first. What we've done on this next operation, we right-click, edit, is under geometry, we've got rest machining checked. So this is pretty cool because Fusion recognizes the 1-inch diameter material that's already been removed. So if you take a look at where the blue toolpath will start, when I click on the boring op, it's going to start right where the drill ended. We do a quick simulation. We'll jump through the drill and start with the boring tool itself. And like so. To change our radial depth of cut, that's the spacing between each line or how much the boring bar is taking on each pass. Under passes, adjust your maximum roughing. It's called step down here. Not the best word, but let's take it to something much, much bigger like 0.1 inches just to show the difference like so. So let's talk about boring some specific areas. This is a question that we get a lot. How would we bore just this front chamfered edge? Right click, edit. The way we've controlled that toolpath is by setting the front to be the stock front, which is kind of the default setting, but the back mode we've picked as that edge right there. So again, if we turn this off or say had it set at model back, it's going to bore through pretty much our whole part. What we're going to do though is again restrict the back to be a selection of just that. The other thing we've done here is we've turned off all roughing passes. That's why we're only seeing a finished pass. We do a simulation, no stock, come in, you can see it's going to come in and make that pass and retract back. So why are we getting the alarm error? We hover our mouse over, we can see holder collides with stock. So that's one of the shortcomings in Fusion 360 Lathe Cam is, unfortunately, it's correct that the holder is colliding with the stock. We can see it right here. Unfortunately, that's not what our boring tool actually looks like. And right now, at least in Fusion 360, we don't have the ability to edit that tool and better control the actual shape of the holder. So unfortunately, it's something where you've got to just understand. We tend to focus on where's the insert going itself. So when we simulate, we'll often turn from tool to just the flute, and that's going to show just the insert. And so I can see, okay, I'm comfortable with how that's working. And the boring bars that we use tend to have a rounded radius edge, so we would be comfortable with that. But you've got to be very careful on that with any lathe work. You can also use what I like to call heights. It's actually called radii, though, to control your tool path. So let's say we want to cut just this fillet area, like so. Come in, clear it like that. You would do that by, under Edit, Radii, you could control the outside and inner radius. So outer radius would be a selection of this line, inner radius would be an edge of that line like so. Another common question is, how do I control sort of the lead in and lead out point? This can be especially important with a boring bar where if you're doing work up here, you don't want it to come in sort of at the center of your part, because it may be the case that the back side of your holder would be crashing with the back side of your part. We do that in this example here, showing the control under radii. Your clearance diameter is going to drive this, and so what we've done here is changed it to be the inner radius, which is the area where we're cutting with a negative 0.1 offset. And what that does is it means it's only moving 0.1 outside of that area. You could accomplish it in a similar way, and sometimes it's more intuitive, by just setting it to be an actual diameter. So let's say we wanted it to never come inside of a 1-inch diameter. We look and see where our clearance tube is, the orange circle right here. We should see that toolpath start right at it, and sure enough, that's going to prevent that boring bar from coming back on the negative side of our 0. And lastly, you can use both the radius and the containments to control the toolpath. In this example, let's say we wanted to come in, sweep along that fillet, come down, clean that up, and retract back out. We've got a front side selected of the face, and I added 0.010 of an inch. We aren't using the back side, but we are using an inner radius of the inside bore diameter right there. And let's say we wanted to control that toolpath so it wasn't, again, coming all the way back to close to center. What we could do is under Edit, Radii, I would change my clearance to be from the inner radius with a negative 0.125, and that'll come 1/8 of an inch inside of that inside bore diameter when it leads in and retracts out. Again, 2 different ways to use these. We recommend you download the template file. You can either right-click on an individual operation and copy and then paste that into your own file, or if you're going to use them a lot, you can make use of templates by clicking one or more, right-click, store as template, and that will let you apply it to any file without having to first open this file to copy and paste the operations. Thanks for watching, folks.